Ciao Roma, come state? Sono molto felice di essere qui oggi perché è praticamente la prima volta che sto parlando su una conferenza in Italia. Sono stato un po' in giro per il mondo, però oggi finalmente ce l'abbiamo fatta. Però mi hanno detto di parlare in inglese, perciò cambiamo. All right, so what we are going to talk today about is lazy loading on steroids, and we are especially going to see how Angular elements can help us with that. So first of all, who am I? Now, Juan mentioned already some of the stuff. My name is Juri Strumpflohner. I'm a Google developer expert in web technologies, mostly Angular. I recently also became a Cypress ambassador. Cypress is that new modern end-to-end testing framework. So if you haven't checked it out, definitely go and have a look. Now, I'm coming from the very northern part of Italy, just below Austria. So in South Tyrol, we have really cool hiking and skiing areas there, so you should definitely come by. And so I'm working there on the front end mostly, but not only. I'm also a trainer and consultant. I'm also an Eckhart.io instructor. Eckhart is that online learning platform mostly made for web developers. And so these are some of my courses, so if you're interested, definitely check them out. All right, so what's one of the big problems, if you go to those new modern web applications? Now, most often you enter some kind of URL, and then what you get is some kind of loading app and some really cool, fancy animation. And as nice as they can be, that's actually not what we really want, right? Because what we should optimize for in our application is really that startup speed. And you can measure that startup speed with a so-called TTI. It's a time to interactive, which basically means how long does it take for a user until it can actually click buttons, enter some text in some forms, like play with our app. And so one member of the Chrome team, an important one actually, is Adi Osmani, and he published a blog post in 2018 about the cost of JavaScript. And what he figured out is that actually nowadays, in modern web applications, the biggest cost is actually the JavaScript. So it's not maybe the images or other stuff, it's really JavaScript. And so obviously he advocates and says we should try to keep our bundle as low as possible. Of course, first of all, that will help us with the download speed, because it downloads faster. But it also will reduce the memory pressure on the devices and also the CPU costs. Now, of course, on your new iPhone 11 Pro Max, whatever, you don't gonna feel that much than on the low-end devices, of course. So what we actually want is to reduce that initial bundle size. Now, Matthias already mentioned some of the things in his keynote. And in Angular, we are actually really lucky, because in version 8, for instance, they introduced a couple of new features in the CLI which really help us already optimize for that low bundle size. So one of them are performance budgets. Now, performance budgets, you can think about them like a threshold, which you configure. Like you tell basically, whatever my bundle goes over 300 kilobytes, I want to get a warning. If it goes over 500, I want to get an error, and my build should fail. And this is really powerful, actually, because you can integrate that in your build pipeline. And so whenever someone enters or adds a new library, which is too big or not optimal, your build will fail, and you can immediately have a look what went wrong. And so it's like having a signal that contacts us and tells, look, there's a problem. And so here are some of the links where you can see what performance budgets are and how you can configure them for the Angular CLI. Another important thing is the differential loading. You've also heard about that already. There's basically the possibility to create different bundles. Nowadays, with the version 8 of Angular CLI, we create different bundles, one for the older browsers, which obviously is a bit larger, and one for the new modern browsers. And as you can see here on that slide from Igor Minar, from NGConf, like on Angular.io, for instance, they were able to shave off more or less 20% on the Angular.io website. All right, but what we want to come at today in the talk is actually lazy loading. So what does that mean? Like in lazy loading, what we want to aim for is to really ship down just the code that actually needed to boot our app. So we don't want to ship anything else, but then when the user starts to click on buttons and interact with our app, we're dynamically fetching new code, instantiate that, and render it finally to the user. Now, one of the most known, and you probably all have seen that already, is route-based lazy loading. So with the Angular router, you can specify a path. So here the about page. And then we don't reference the component directly, as you might do, but rather we use such a dynamic import statement. And so here, for instance, we load that about module. And with that, then Webpack behind the scenes and the Angular CLI knows that it has to create a different JavaScript file, which can then later be fetched on the fly over the wire. Now, probably if you're using a version less than version 8, you have used such a magic string. Nowadays, that has basically gone because it's not natively supported, as also Matthias mentioned in his keynote. So what happens? Well, if you go then to the About page, and you open also the network tools in Chrome or whatever browser you're using, you navigate to the About page, and you will see that an additional JavaScript will get downloaded. And that's when you know actually that lazy loading worked properly. Now that's really nice and works quite easily and can be implemented really fast. But often that's not enough. Especially in large enterprise applications, there are more sophisticated requirements. So if you take a look at this real-world application, for instance, you see like a really huge menu on the side with a lot of different kind of entries. And these are, of course, all lazy loaded via the route-based mechanism. And then in the central area, you see grids and filters and other kind of stuff. Now, when users enter in those details of one of those grid items, you have normally a huge form, like I just cut that out here. And at the very bottom, you have tabs with other lists and other grids. And that can go on and go on as long as the user wants. And the reason is that enterprise users want to have as much context on the screen as possible, because they have to work with the app on a daily basis. And so here, of course, I don't want to eagerly load all of those tabs with the lists and grids and whatever. For instance, the second and the third tab here, I only want to load it when the user actually clicks on it. And so this can go on, even like when someone clicks then in a grid item here, and maybe a pop-up pops out, and another component is in there. And I also want to lazy load that one, of course. So what I want to arrive at is some kind of lazy loading of non-routed component, right, which we can programmatically steer. So how could that look like? Well, if you know the smallest unit right now, and therefore is that star, is the ng module. It's the smallest unit which we can actually lazy load in Angular, which is also what you use, for instance, in the router configuration. And so lazy loading an ng module could, for instance, look like the following. So I could create my lazy loader service, which I've just created here. It has the load module method, and what I pass as a parameter in there is that dynamic import. And we have seen before that with that dynamic import now, Webpack already knows it has to create a different bundle for it. And so with that, I'm already fine. Now, the implementation itself can look, for instance, as the following. Like I get that path, which is that dynamic import function, in my load module function here of my service, which I created. And then I get back either a promise of a factory or a type. Now, this distinction here is important because this varies slightly based on whether you're running on Ivy or on Vue Engine, whether you have AOT activated or not. Now, I didn't put all the details here. I've written a blog post last week, so you can, in case, check that out. What's important for us is just to know that in the end, we get such a module factory. And from that module factory, via the injector, we can actually instantiate programmatically a new module. And so at this point here, we have now lazy loaded our ng module. Now, of course, we have to do something interesting with it. And that's lazy loading and instantiating a component, right? Because the module is just the means for us to get to the component which we actually then want to display on the page. So how does dynamic instantiating components work in Angular? It's more or less the following. It's not that important to know all the details here, just to get an idea. So we need to have the type. Then we have such a component factory resolver, which gives us a component factory. And then via the view container. The view container, you can imagine, is where the component then gets inserted, like another component or a template. And then via that, we get finally the instance. And then on that instance, we just set the input properties. Like normally in your template, you have that add input properties. And here, obviously, if you have it in memory in TypeScript, we just set them as normal properties. All right. But obviously, the component needs to also be inserted in some template, because otherwise it's there for nothing. And so what you usually then have is some kind of hook element. A hook element is a place where you then append or insert your component which you lazy loaded. Now, obviously, you need to give that hook element some kind of information, like which component do you want to lazy load. For instance, here, I gave it that do-greet selector, and then the hook element basically goes and takes the selector, it looks it up on some map, knows which ng module to load, loads that in, and dynamic instantiates, and then inserts it right in here. Right. And so some libraries already take that approach. For instance, the HeroDev's Hero Loader has that approach where you give it the module name, or also NGX Loadable. And these are really great libraries that work perfectly. You should definitely also check them out. But when using them, I was thinking, like, maybe we could do better, like not have a special component to lazy load another one, but rather just lazy load our component. For instance, here, I have here my demo application, which has a tab here, and I just want to lazy load that ticket list down there. So I don't want to do any extra stuff, or as little as possible. So you shouldn't see it. And that's when I thought about Angular elements. Now, if you didn't yet check out Angular elements, I have a course on Egghead, which really starts you at nothing and goes you through the basics, things you have to know. But in principle, you can install it via that useful ng-add command. And then what you get is that create custom element function. And the create custom element, you can think about it like an adapter or wrapper. It takes your component and it wraps it for an Angular element. Once you have that, you can then pass that instance to that custom elements method. And that's actually a native browser API. And so with that, you tell the browser, look, whenever you see that tag, just use that object to render that tag. And that's also what people usually do with Angular elements, like they compile it down into a different bundle, and then you can just include that bundle and use it whenever you want in any kind of static page, or even in a React app, Vue app, whatever you like. But you can also just use it in an Angular application. You don't have to create necessarily a different kind of separate JavaScript file. For instance, here, it's actually really hard to tell whether this is an Angular component, just a normal one, or it's an Angular element. It could be both. Like you cannot see it. And that's because Angular has really first-class support for Angular elements. Like the whole input binding works just as expected. The whole attaching of event handlers just works. And so the only thing which you have to do is to add that custom element schema, because what happens otherwise is Angular will complain when it sees that tag because it has not the corresponding Angular component in its compiler, and so it will basically give you an error. And so with that, Angular would recognize that custom element. So basically, we have to register it wherever we want. It could be an app module, wherever you like. And once it is registered with the browser, we can just use it. So we can just append it into the DOM. And that's when my idea came, well, this is a really nice fit for our lazy loading, right? So how could it work? For instance, here is our normal Angular component, just to do grid as we have seen before. And now my idea was, if I apply here a directive, I could trigger the whole lazy loading via that directive, and also wrap this as an Angular element on the fly and just visualize it. Because once it is registered with the browser, it will work, because the browser will render it and take care of it. So in principle, it works like this. Like you have the directive, and besides triggering, of course, the lazy loading, I needed to get access to that tag, because I need to know which element should be loaded. With that tag, I'm then looking up a kind of a registry. It's very similar to like the router configuration where you have the path. Here you have a selector and the module reference, which you want to lazy load with that dynamic import statement. And so once I have that, I can now lazy load the module, in this case, the greeter module. And inside the constructor, I just wrap it as an Angular element, a component which I want to wrap. So how does the implementation look like? Well, first of all, as mentioned, we have that lazy elements registry, just mapping between selector and lazy module function. Now, inside that greeter module here, I just expose the component which I want to expose as an Angular element. Now, I did also automate the whole creation of the Angular element, and so I defined just a custom property here, custom element component, and exposed that I want to have that hello world component later on lazy loaded and wrapped as an Angular element. So how does the directive look like? Well, first of all, you see that star in front. The star means because it's a structural directive. So it means, like the ngIf, it's not inserted immediately into the browser templates in the DOM, but rather I can control when to insert it. And the reason is I want to delay it basically as much as possible to the point where the actual Angular element is lazy loaded and registered to the browser. In order to get access to the tab, to the template, I need to basically render it in memory first, which I do here. And with that, I get now that tag which I want, the selector basically, and that's what I can pass on to my component loader, which will then take care of lazy loading the module and instantiating the component. Once I have everything, I can clear the viewport, basically here the view container, and then render the template to the DOM. And now the browser already knows because it has been registered to the browser before, and so it just renders it out. Now the component loader inside works very similar to what we have already seen before. Like I just get those tags. I need to look up at that registry to know, basically to get access to that selector function, to that lazy loading function of the module. I pass that on. And inside there, basically, it works just as I told before. So I invoke it, I get a module factory, I have now the instance. With that instance, I can access that custom element component, which we have seen before, which I defined. And with that, I can then automatically wrap it as an Angular element. How? Well, I just import also the create custom element function here. I pass in the component which I just got, which I just extracted, the type basically. I have now my custom element, and I register it with the browser. And so that's it. So with that, it theoretically works, because the browser now knows basically what my element is. All right. So if we take a look here, we have basically my template on the side, which I mentioned before. And so how did that actually change? Well, I have my template, and the only thing I had to apply here is now that NGX lazy element. And with that, I trigger then the lazy loading, right? So how does that work? Let's see in the code base. So I have here my application. Let me make this a bit bigger. All right. We have the network panel below. And here I have that assign tickets tab. Now what I want to know here, or what I want to show you, is how that actually works in practice. So I want to lazy load the content of that tag. Let's have a look at the code first. Below here you can see basically my custom element, my lazy loaded Angular element. Now you might notice that I'm using here the dynamic element. Now the reason here is that I want to explicitly tell other programs, look, this is a custom lazy loaded element, but I could just use up ticket list just as normal. Now the first thing I have to do is actually create a configuration, which I mentioned before, like that dynamic element map. And so you can see here I have a couple ones. What we are interested here is in that ticket list dynamic component. So I define here the selector, and I can give it whatever selector I like. And then I have here that dynamic import statement, which is just the same, like I left it exactly the same as with the router. Next, if I go to the tickets module, which is here actually what is being loaded, I have to expose my ticket list. And here I have multiple components exposed, so I even provided a kind of a map. This is what we are interested in here. So here I have my ticket list, and I again match it to the same selector, which I need to use outside. Now finally, in the user module, I normally have a reference to the tickets module, of course, because the list component is part of the tickets module, while I'm showing here the user detail, which is part of the user module. And so in order to use the components, I have to export it on the ticket module and have to import it on the user module. Now this is no more necessary because, as we are trying to do here, we are going to lazy load it. As you can see also, I import here the custom element schema, and with that basically it should work. Now if we take a look here, if you see the network panel below, if I now click the assign tickets, you can see that the JavaScript gets loaded in on the fly, just as I click the assign tickets tab here, and we see the actual ticket list. So you can see how it has been lazy loaded on the fly just when I clicked basically in there. And all it was necessary was to apply here that NGX lazy element. All right. Now, of course, I showed you more or less the flow, how the implementation works, like at a high level. There are some more details, like handling multiple registrations of the lazy elements and some more subtle details. So you can definitely check them out here on that NGX lazy element repository. I also published it on NPM. It's right now RC1, so take care. The API might still change. I'm testing it out right now. But I'm already using it in a production app, and it works just fine. All right. Now, before concluding, I need to make a note about Ivy. Because as also Matthias mentioned in his keynote today, Ivy not only brings us like a better compiler, more speed, of course, because the bundle is basically smaller. But as Igor mentioned in his Angular Connect talk this year, Ivy is really an enabler. Like Ivy opens up a whole new set of features which have been just waiting till actually Ivy gets out. And now finally with version 9, we're there to get it started. And so what Ivy brings, and what I'm particularly excited about, is that in Ivy we'll then finally have lazy loading at the component level. Now, I in the talk showed you some kind of like way to work around the limitation that we have to go over ng modules and that kind of thing. But what you see here, for instance, is that in that dynamic import statement, which we have already been using before to load the modules, you can now actually load the component itself, as you can see at the very top. And so, for instance, here is a simple example of opening a material dialog. This is really, really useful now and really powerful, because especially for dialogues, I don't want to load the component until the user actually clicks the dialog, because it might never click it actually. And so you can see here, I get a component in, then I don't get any more in the module, but rather actually the component type. And the material dialog is everything it needs is actually component type, and so it will just work. So that's going really, really awesome. So to conclude, the whole lazy loading with Angular elements, I think it can be quite a powerful approach because you can have some kind of component level lazy loading. It's even highly dynamic because I couldn't show you today because of time restrictions, but rather you could also even construct basically that selector on the fly, like as a string, and then just embed it in your DOM. And if that specific element is registered, it will lazy load and will just work. Also, what I really like about this approach is that you can actually use the actual component in your template, and in the template you don't really recognize, apart from some minor details, that it is a lazy loaded component. It's a template-based approach. The only downside, if you will, is really that you have to register that custom element schema, and as a result, you will get a bit of a worse template checking from the Angular compiler because it might not catch basically typos of your existing Angular selector components. All right, I would like to thank especially those three guys. They were really helpful in discussing back and forth how the API could look like, and mostly how I can make this work in Ivy and Vue Engine, because even after version 9, you could still run your application in Vue Engine, even though Ivy is basically the default one. So if you have questions, definitely check out my Twitter handle or my website. Also, I'm publishing on a regular basis some news as part of a newsletter, where we'll also basically send out the slides. And I will just be around afterwards, so definitely come by and say hi. Thank you.